my name is Abhishek Ken, and in today's video, we're gonna see what is network in a Docker world and how to use a network to isolate, the container communication or to allow the container to communicate. So network is pretty much same like what we have in general, where we want to have a communication setup between the devices, right? So it's pretty same concept, and a Docker is utilizing the same concept to establish or isolate the communication among the containers. There are few default network providers or the network driver which Docker provides to us for use, and there are some third-party network driver also which you can use depending upon your use case. So let's get into the demo part and see how we can control this network component of a Docker. So for that, I'm just assuming that you have Docker installed on your machine, and then Docker provides you one component which is Docker network, and then you can just put help. Okay, so here you can see that you can connect, you can create the network, you can disconnect, inspect, list down, prune, and rm. So when you install Docker, by default you get three network drivers, or I would say a three network created. The first one is bridge, then you have host, and you have none, right? So bridge is the default network driver which gets used whenever you create any new network. So let's see with the example. If I just wanted to create a network called, let's say, first network, and I'm not providing any driver. So let's see if I just run this network ls. Okay, so now I can see this first network, which is the name of my network, and then we have a bridge as a driver. So what is actually a bridge? Bridge is nothing but it just provide a tunnel or a mechanism through which one container can interact with the another one, right? Why do we need to create a different network? Why cannot we use the default network which we already have, right? So that completely depend upon what exactly, for what purpose you are building your containerized application and how you want to establish the communication between those containers, right? Now I have some bunch of the containers which are running. For example, first Postgres, then I have a Kibana, then we have Logstash, and we have Elasticsearch, right? So if I just bring back that Docker network ls, you can see there is a one network which I had created, which is the name of that network is Elasticsearch, Logstash, Kibana. So this is for the Elasticsearch. If you are not aware of that, this is just a one log analyzer tool which requires three major components: Elasticsearch, Logstash, and Kibana. But that is not the purpose of this video. Is not meant for covering that, but this one is actually using a network component to establish the communication between these different components. So if I inspect, so Docker network, inspect this network, let's see what we. Okay, so now if first thing we have a name, then we have an ID of this, and then we can see the driver, which is bridge in our case. Now the networking component, which is important, like subnet and the gateway, right? Subnet is which actually decide the IP range for your network. So here I'm just using this 172.18.0.0.016, right? So whenever you create any container which going to join this network, that, and we know every container get assigned a one IP address. So for if your container is going to be initiated or connected to this network, then your IP would be starting 172.18, then rest of the two things would be different. It could be 0.1 depending upon which IP is available. Now if you just come down, then you can see there is a containers, right? So in containers you have three containers. The container name is es, log, and kiv. And if I just show you this on one of my Docker ps. Okay, so now you can see we have this kiv, log, es. So these are the three containers which are running on this network, right? But this first Postgres which is not running in this container. Now just observe this IP address. We have 172.18, so it's starting with these 172.18, but rest of the thing is 0.2. Why? The 0.1 is for the gateway, and now the next available IP is this one. So this is getting assigned for the first container, then we have 4 for the second container, and 3 for the third container. But this is how those IP just get assigned. Okay, now how can we check whether these container can communicate with each other or not? So there are many ways. The first and the simplest way, what I'm gonna do is I'm just going to get inside one of the container like ES, and I'm just going to get the bash mode. Let me just see ping, if I can do a ping. And I'm in ES. For ES, this is 172.18.0.2, which I'm highlighting. So let me just ping this to 3, and let me just give packet 5. Now it can communicate to this, right? But let me just inspect let me just inspect a network uh, bridge. Okay. Oh, I'm inside the container. Okay. So let me just um, oh, just making a lot of mistake today. Okay, so now in this bridge network, which is a default, I have this first Postgres, right? And now here you can see this. We have this is the IP assigned to this container, and you can see the subnet and gateway, right? So now let's see whether my ES container can communicate to this IP or not. So let me just get inside this ES bash, and let me just ping C two packets 172.17.0. Okay, this is my IP, which is for container first Postgres, and see it just hang there. It is not able to communicate. So that is how you can isolate. So right now Postgres is running in, uh, see it's completely lost, so it is not able to communicate with the first Postgres, which is lying in a bridge network, whereas ES is lying in a different network altogether. So that is how you can isolate the communication of the containers within a network. And there are several times it happens in a testing environment when you want to have a different network, because in real time in a production environment you have a different network, and you want to mimic that on your local environment, and that is where this network component becomes very handy, right, for the test purpose. And bridge is the one which we can use for the testing purpose, but not for the production use. For production use, there are many more different network types. So we this is the bridge one, then we have an overlay, and there is a third party one which is Mac VLAN. We have IP VLAN as well. So that depends. When you have a distributed application, maybe your Docker daemon is running on a different machine and you want to have some kind of connectivity between them, at that point of time you can use Mac VLAN, right? So but this is completely depends upon your use case, which one you want to use. But from the basic understanding perspective, that is how the network component of Docker work. Okay, so now the next thing is Docker network ls. What's okay? I'm inside the container. Let me just come out and just put this network ls. Okay, so now we just understand the bridge. Same thing with host. Host means is you do not want to create your own network for the container. You want to utilize the host machine network. But the caveat with that is, in a host machine, and in a host machine you can use only one port, and you cannot have a different IPs over there, right? Because you are going to use a host network, and host has only single IP, right? So if you want to run your container by using a network of the host machine, at that point of time you should be using a driver as a host. None means you don't want your container to be a part of any network, and that container is completely isolated from the network perspective. So it means that it cannot communicate with any other container, or none of the outside traffic can communicate with that container, which is actually created by having a network equals to none, right? So that's it from my side for this video. And I know there are a lot of stuff which I wanted to cover, and I will be coming up with a follow-up video where I will be explaining a little bit more about networking, and then we're gonna see how we can control this network module of a Docker from the Python programming module, which is again known as a Docker. So that's it from my side for this video, and thanks for watching this, and stay healthy and keep learning.